Welcome to another explainer. So, have you ever looked at a complex math equation and just felt your brain instantly shut down? Look, don't worry, you are definitely not alone. I mean, a lot of us break into a cold sweat just trying to figure out a tip at a restaurant. But what if I told you that mathematics isn't actually about numbers or equations at all? It's fundamentally a language. Literally, the universal language of our universe. So today, we're going to learn how to decode the grammar of mathematics, and we're going to transform what looks like a totally confusing jumble of symbols into clear, concise, and just incredibly powerful sentences.
Okay, let's dive right into this. Take a look at the nautilus shell on the left and that pineapple on the right. Now, these aren't just beautiful pictures. They actually represent how mathematics visually expresses itself literally everywhere in nature's grand patterns. Those spirals you're seeing? They are perfect visual representations of the Fibonacci sequence, which is a mathematical pattern where each number is the sum of the two before it. Math isn't just trapped in some dusty textbook. It's this hidden code that actually shapes the reality all around us. But to read that code, we first have to understand its language.
Just listen to these phrases for a second. 나는 K-pop을 정말 좋아해요. Or how about je ne veux pas ce plat? Now, unless you speak Korean or French, those words probably mean absolutely nothing to you. And that's the thing. Even the simplest, most basic thought becomes completely impossible to comprehend if it's presented to you in a vocabulary and syntax that you just haven't learned yet. Think about how that actually feels. It's totally disorienting, right? You just feel locked out of the conversation. Well, people constantly struggle with mathematical ideas. Not necessarily because the concepts are too hard for them, but honestly simply because they're being presented in a foreign language. That anxiety you feel when you look at algebra, it's the exact same language barrier you experience when you're staring at a menu in a foreign country. But the good news is, once we recognize this barrier, we can finally break it down, unlock the subject, and realize that we really just need to learn the vocabulary.
Because as this quote beautifully sums up, mathematics is a universal language. It's a special kind of language shared by all human beings, completely regardless of race, gender, or culture. Just think about how amazing that is for a second. If you write out an equation in Manila, an engineer in Paris or a doctor in Tokyo can read it and understand it perfectly. It is really the one true language that unites human understanding all across the globe, and it's one we can all learn to decode together.
So, what makes this language so special? Well, it boils down to three core characteristics. It's precise, it's concise, and it is absolutely powerful. And this is exactly why professionals rely on it every single day, right? A medical professional calculating a life-saving medication dosage relies entirely on its precision. An engineer who's building a massive suspension bridge relies on its concise formulas. And a teacher shaping young minds uses its powerful logic to explain super complex real-world phenomena with relative ease. Mastering these traits really helps us communicate big ideas. All right, let's learn the grammar. We are going to start with the absolute most building block, which is the mathematical expression. You can think of an expression as the exact mathematical equivalent of an English noun. It's just a correct arrangement of symbols used to represent an object of interest. A name given to an object like a number, a set, or a function. But here is the catch. An expression doesn't actually state a complete thought. It doesn't make any sense to ask if an expression is true or false, just like it wouldn't make sense to ask if the word car is true or false.
On the other hand, we have the mathematical sentence. Now, this is the equivalent of a full English sentence. It's a correct arrangement of symbols that expresses a completely standalone full thought. And because it's a complete thought, it now makes total sense to ask about the truth of the sentence. This is where we graduate from simple objects to evaluable ideas, where we can literally look at a mathematical sentence and ask, hey, is this true or is this false?
And this brilliantly illustrates the exact parallel between the English language you already know and the language of math. It makes it instantly accessible. Take Mr. Reyes, for example. That's just a noun. But Manila is the capital is a full sentence. It is the exact same thing in math. 3 plus 4 is just our noun. It's an expression naming an object of interest. But 3 plus 4 equals 7? That states a complete thought. It's a full sentence that we can actually evaluate.
Now you might be wondering, if math has sentences, it must have verbs, right? Absolutely it does. The most popular verb in the entire mathematical language is one we use all the time, the equal sign. If you look back at our sentence, 3 plus 4 equals 7, and read it aloud, you're saying 3 plus 4 is equal to 7. You can literally hear the verb right there in the middle, driving the whole action of the sentence.
So what about the plus sign? Well, think of symbols like the plus, minus, or multiplication signs as conjunctions, kind of like the word and. They act as the glue connecting our mathematical nouns together. In our mathematical grammar, we call these connectives, mainly because they simply join objects of a given type to create a compound object of the exact same type. Once you understand these basic grammar rules, really all you need is a translation dictionary reference guide like this to turn everyday English directly into mathematical symbols. When you hear phrases like the sum of or more than, your brain should just automatically translate that to the addition connective. The product of or twice translates to multiplication. And words like is, amounts to, or yields, those translate directly into our verb, the equal sign. Let's actually put this into practice and build up your fluency with a rapid-fire exercise. Think of this like a fun little puzzle we're solving together. How would we translate the phrase 8 more than a number into math? Remember, a number is an unknown, so we can just use a variable, like x, to represent it. Got it? Now what's really fascinating about this slide is how perfectly concise the translation actually is. 8 more than a number translates beautifully to simply x plus 8. It's an expression, a mathematical noun. Just notice how much more concise the mathematical language is compared to the English language. I mean, 3 symbols replace 5 words, yet the meaning remains entirely intact. Pretty cool, right? All right, let's step up the difficulty just a little bit and try translating a complete mathematical sentence instead of just an expression. Listen to this one. 3 less than a number equals 11. So let's break it down piece by piece. We have our unknown number, we're taking 3 less than it, and we have a very clear defining verb right smack in the middle of the sentence. Take a quick second to picture those symbols in your head.
And here is the answer. X minus 3 equals 11. Notice how the English word equals translates perfectly into our mathematical verb here, completely dividing the sentence into 2 balanced sides. And because this has a verb, it is a complete, fully fledged mathematical sentence. Let's do one final test of your new grammatical fluency to reinforce everything we've established. We have 9 minus 5 equals 4. Based on everything we've talked about so far, is this a mathematical expression or is it a mathematical sentence? And secondly, because of what it is, can we actually evaluate it as true or false?
So the absolutely crucial point here is that because it contains the verb, the equal sign, it states a complete thought. Therefore, it is definitively a mathematical sentence. And if we evaluate that complete thought, we find that it is, in fact, absolutely true. 9 minus 5 is indeed equal to 4. Look at that. You are now successfully reading, comprehending, and evaluating the universal language. Let's bring this full circle and see how this builds our understanding of the world. Check out this incredible image of Romanesque broccoli. Just like the pineapple and that nautilus shell from the very beginning of our explainer, this broccoli grows in perfect Fibonacci spirals. 13 spirals clockwise, 8 counterclockwise. See, when we understand the grammar of math, we unlock nature's patterns. We stop seeing a chaotic world and we start seeing the precise, beautiful sentences written into the very fabric of nature itself. Mathematics is definitely not something to be feared. It is literally just a language, one with nouns, verbs, sentences, and syntax. And it's a language designed to help us solve problems. Whether you're working in a high-tech engineering firm, a fast-paced medical laboratory, or even if you're just marveling at the spirals in your vegetables. So I want to leave you with this question. How might your newfound fluency in this universal language change the way you see the hidden patterns of the world around you? Thanks so much for joining me on this explainer, and keep looking for those patterns.